Mercury and Venus have no moons. Mars has 2, but they could easily pass as space potatoes. The gas giants have a whopping 400 known moons. And Earth, well, we've just got 1. And somehow it's kind of perfect. In today's video, we look at Earth's moon and why it's so incredibly special. Because once you look closely at the moon, you see that it's not normal. So about 1/4 of the moons in the solar system are small, lumpy, and not very moon-like. The rest are honestly pretty interesting. In my opinion, way more interesting than the planets. But Earth's moon is probably the best for a couple of reasons. Number 1, it is huge. Now, it's not the largest moon in the solar system. That title goes to Ganymede, one of Jupiter's moons, but compared to its planet, it's gigantic. If the Earth were the size of a basketball, the moon would be roughly the size of a softball. But if Jupiter were the size of a basketball, its moons would be no bigger than grains of sand. Phoebe! And the moon doesn't just exist, it does things. Really important things. Like first, it gives us tides. The moon's gravity pulls on Earth and the Earth's oceans, causing them to bulge, which mixes nutrients and water, and it shapes coastlines. And it's probably the reason why life first left the oceans and went onto land. I've got a whole video on tides if you want to check that one out. Second, the moon gives us stability. Now, the Earth tilts on an axis at about 23.5 degrees, and that's what gives us seasons. And without the moon, that tilt would wobble wildly over time. Seasons would go from extreme to extreme, and it would be nearly impossible for life to survive in those kinds of conditions. I've got a video on seasons too. And then there's this, total solar eclipses. Now, while the moon is 400 times smaller than the sun, it's also 400 times closer to Earth. And as a result, the sun and the moon appear almost exactly the same size in the sky. That is an astonishing coincidence, and no other planets have anything like that. And for a brief moment, the universe aligns, daytime turns to darkness, and the sun's atmosphere glows around the silhouetted moon. It's beautiful, it's rare, and it only happens here. And here's the big question. If moons are so plentiful and so useful in our solar system, why does Earth just have 1? And the answer lies in where our moon came from. Well, for many years, scientists had 3 main ideas that they thought might be the reason why we have a moon. First was the Co-accretion Hypothesis, that the moon was just flying by and Earth's gravity sort of grabbed it and got it to go into orbit. And that does happen in our solar system. Usually those captured moons have really weird orbits, and our moon's orbit is perfectly normal. It's almost like a circle, and our gravity isn't nearly strong enough. That would be like a baby on the side of a bowling alley trying to catch the bowling balls that passed by being thrown by Jason Momoa. Second, there was the Co-accretion Hypothesis, that maybe the moon and the Earth both formed at the same time out of the same bunch of gas and dust that was in the early solar system. But if that were true, they'd be more similar in size, and they'd have the same amount of iron in their cores, which is quite different. And third was the Fission Hypothesis, that the early Earth was spinning so fast when it was all molten that it just kind of shot the moon off in globs, like a tire full of mud on a bike. And that's a fun idea, but for that to happen, the Earth would have had to have been spinning so fast that it probably still wouldn't exist. Now, each of these ideas sounded pretty good until science and mathematics proved them wrong. So where did the moon come from then? And the answer came from a most unexpected place. Actually, it was quite expected. It was from the moon itself. Astronauts in the late 60s and early 70s of the Apollo missions brought back over 800 pounds of moon rocks to Earth to be studied by scientists. And those rocks told scientists something that made them rethink everything. And that's what we'll cover on our next episode. We'll talk about where the moon actually came from. So until then, stay curious.